Hello everyone and welcome to my channel. My name is Dr. Karachi, and in this video we will discuss advanced threat detection techniques with a focus on anomaly-based detection. Now in this video here we're going to cover what is anomaly-based detection, what methods apply, what is the architecture design briefly, what's the advantages versus disadvantages, corporate scenarios, and the difference between anomaly-based versus behavior-based detection. And of course, you should have watched my video about the behavior-based detection. Now, what is anomaly-based detection? Well, it's a technique for identifying and classifying events that deviate from something that's considered to be a normal pattern or behavior. The good thing, it does not rely on the signature or non-attack patterns. Instead, it relies on statistical models or machine learning algorithms to learn what is normal behavior. Then it will flag it if it's deviate from the normal as a suspicious. Now, there are two-step approach that involves. The first step here, you need to train the system with the data to establish some view of normality. Second thing, the use of established profile on the real data to flag deviations. So it is effective at detecting new and unknown threats, as it is not limited to identifying only known attacks. The good thing about it, it is adaptable to changing network traffic patterns and can be used to detect both insider and outsider threats. Now, let's take a look at the methods applied. So what are the methods? Well, in the context of anomaly-based detection, methods refer to various techniques and algorithms used to identify and classify events that deviate from normal or behavior or patterns. These methods are often based on statistical models or machine learning algorithm. Now, the first here, obviously, the machine learning technique, this technique, they use machine learning algorithm to analyze data and detect anomalies, which include learning algorithms such as clustering, classification, and deep learning algorithm. That's very complicated algorithm, requires a deep understanding of how it works. The second one here, the statistical techniques. These techniques involve using statistical models to identify anomalies. Like, think about it like unusual fluctuation in the performance of the server. And they can be effective in detecting outliers in the data. Now, what outliers or what outlier means, these are the data points that deviate significantly from the expected or normal patterns in the data set. The other one here, we have data mining techniques, which involves the process of discovering patterns and knowledge from large amounts of data. It can be used to detect anomalies by identifying patterns and that deviate significantly from expected behavior. Rule-based techniques, it has a set of rules, of predetermined rules to identify anomalies. The rules are often based on the knowledge of domain experts. So, now according to research from different resources and different online resources, so I'm going to talk about architecture design. The first step here, obviously, we need to do data collection, which, you need to collect data from various sources like network traffic, system logs, and user behavior. Then you need to extract the features. You have to use this collected data. You need to process it and to extract the relevant features. Now, these features are basically what we call it the data characteristics that can be used to distinguish normal behavior from anomalies. Then you need to establish a baseline. The system is trained on a normal behavior data set to establish baseline, which means that the baseline represents what is normal for a state or of a user. Then the anomaly detection, the system, of course, will keep monitoring new data and compares it to the baseline. If there's a deviation from the baseline, it will be flagged as abnormal, unnormal. Alerts and response, of course, once the system detects anomaly, it will send an alert to the administrator or whoever is in charge. And, and also some of the system, it will have a predefined automated actions as well. Of course, there is system update. I mean, the system will continually monitoring data, and the system will always learn and adapts to changes in the normal behavior to improve its accuracy in detecting anomalies. Now let's take a look at the advantages and disadvantages. I mean, number one, detecting of unknown threats. Well, this system is effective in identifying new or unknown threats. Unlike signature-based system, it does not rely on a data set of known threat patterns, making it capable of detecting zero-day exploits and new attacks. Now, when it comes to being adaptable to changing environment, how? Well, by continually learning normal behavior patterns, they stay relevant even as network configuration, for example, changes or legitimate user behavior changes for some reason or another. Proactive security, well, it provides a proactive approach to security. It identifies potential threats before they follow to known attack patterns, potentially, stopping attacks in earlier stages. Comprehensive coverage, well, it covers a wide range of attack vectors since it is not limited to predefined signature. It can detect anomalies in network traffic, user behavior, application performance, and more. Insight into the network behavior, well, see, monitoring for anomalies can provide valuable insights into network performance and user behavior, aiding in optimizing of both security and, of course, operational aspects. Now let's take a look at the disadvantage. The first one, high false positive rates. Yes, that's the biggest challenge with anomaly-based detection, it's because it has the tendency to generate false positive. Like unusual but legitimate behavior can be mistaken for malicious activity, leading to unnecessary alerts and potential disruption of normal operation. Complexity. It does require significant expertise in configuring the setup and maintaining it. The system must be carefully tuned to understand what constitutes normal behavior in a given environment, which can be complex and time-consuming. Resource intensive, well, it is because, resource intensive what? In terms of computational power and storage. These systems need to process large volumes of data in real time and store behavioral baselines for analysis. Need for continuous learning also requires ongoing learning and adaptation to maintain effectiveness. This can be challenging in dynamic environments where network behavior and legitimate user activities frequently change. Limited effectiveness against sophisticated threat. Well, according to the research, like skilled attackers may devise methods to mimic normal behavior or slowly introduce malicious activities to avoid detection, potentially reducing the effectiveness of this detection method. Dependency on baseline quality. This is very important. It is heavily dependent on the quality of the baseline performance. The baseline performance in terms of normal behavior. Because if you introduce inaccurate or incomplete information into the baseline, you will have ineffective detection capabilities. Now, what type of solutions out there? Here we have like the Cisco Stealth Watch. It provides visibility and threat detection capabilities across the entire network. Flowmon, this tool uses network behavior analysis to detect and prevent anomalies from being a threat. You got, of course, IBM Q Radar. It uses advanced analytics to detect network anomalies and provide insights into network behavior. You got also the logarithm mist net. This tool uses AI to detect network anomalies and provide actionable insight. You got NetFlow, network anomaly detection. Also, it has its own method on detecting network anomalies. So one of the things I advise you is that to go over the features and the stuff directly on the website, become familiar with them. It will help you to understand even the topic even further. Now, what are the corporate scenario? Let's look at the first one, where we see anomaly-based detection used in a corporate. There are different scenarios. The first one is the fraud detection. Financial institution can use anomaly detection to identify fraudulent transaction on the credit card, your debit cards. Okay. For example, like if let's say for example, a customer typically spends a few $100s per month on groceries, and all of a sudden, now we have 10,000 purchases at a high-end electronics store. The transaction will be flagged as an anomaly. This could indicate that this card has been stolen or compromised. Network security. If you are a network administrator, you will definitely like to use anomaly detection to identify suspicious network traffic that may indicate malicious activity. For example, if a user on a network suddenly starts making a large number of requests to a foreign IP address, this could be a sign that they are attempting to access unauthorized data or spread malware. Now, for IT operations, IT operation team can use anomaly detection to identify potential problems with servers, network equipment, and other IT infrastructure components. For example, let's say your server CPU usage suddenly spiked to 99% for a long time. This could indicate a problem. Could be with your server hardware or software, or could be some other malicious things. The consumer behavior analysis, can be used by department like marketing. For example, customer service team. They use this kind of system to identify changes in a customer behavior that may indicate a problem with a product or service. For example, if a customer who typically makes purchase every month suddenly stop buying from the company, this could be a sign that they are dissatisfied with the product or service. And sometimes you get an email, try to encourage you or try ask you to do a survey to get your input. The last one, industrial predictive maintenance here. Manufacturing companies can use anomaly detection to identify potential problems with machinery and equipment before they cause breakdowns or accidents. Okay, like for example, if a sensor on a machine starts to vibrate outside of the normal range, this could indicate that the machine is about to fail. Now, a lot of people, sometimes they get confused or they don't understand the difference between anomaly-based versus behavior-based detection. So this is why, before you watch this video, it's very important that you spend some time watching the behavior-based detection. Now, let's take a look at focus. Now, what is the focus of this? Behavior. Identify malicious behavior by examining actions that match known patterns. The anomaly detects unusual activities that deviate from standard behavior. The method here in the behavior, it uses predefined rules or heuristic describing malicious activity. On the other hand, the anomaly establishes a baseline of normal activity, monitors for deviation, use statistical models in this particular detection. We know also behavior must establish normal activity, yes, but in anomaly here, they're using statistical models or machine learning even. Okay, now detection, effective against known threats with documented behavior patterns, anomaly, capable of identifying unknown or zero-day threat. Behavior can still detect zero-day threat, but not as good as anomaly-based detection, according to testing and research. Now, updates, okay, requires regular updates to include new threat behaviors. Here, continuously learns and adapts, reducing the need for frequent updates. Limitation, less effective against zero-day threat or sophisticated attack, yes. Okay, anomaly, prone to higher rates of false positive, legitimate, unusual activities may be flagged. So, to summarize this, the key difference here basically is that behavior-based analysis is centered around known threat behaviors, making it strong against familiar threats but weaker against new attacks. Anomaly-based detection, on the other hand, excels at identifying new and unusual activities but can struggle with a higher rate of false alarms. Now, both methods are, they complement each other in a robust cybersecurity environment. And finally, thank you so much for watching this video. If you like it, please hit the like button and subscribe for more videos. Again, thank you so much for watching.